Okay, here's an example problem for you using refraction. So here's the problem. Light enters the side of a cube of glass as shown in the figure below. For what range of angles theta 1 will the light experience total internal reflection from the top surface? Okay, so the idea is I have light entering here. It's going to bend at this surface. It's going to get to the top surface, and we want to know, are we going to get total internal reflection? For what angles theta 1 will I get total internal reflection up here? Alright, a few things I probably should have noted in the problem. Let's assume that the index of refraction outside of this glass is equal to 1. Alright, and of course, being a cube, these are, doesn't look very cubic, looks more rectangular, but we're going to assume that all the angles involved are right angles. Okay, so how do I work this problem? I want to find what angles here give me total internal reflection up here. So what is the condition for total internal reflection up here? Well, let's just draw a normal right here. Okay, and I'll call this angle right here theta top. Okay, what is the condition on theta top that assures I get total internal reflection? Well, I get the critical point at which total internal reflection begins is when this angle here results in an angle up here. Let's call this theta x. Alright, when theta x goes to 90 degrees, it can't go past 90 degrees. So the critical point where I start to get total internal reflection is when theta top is greater than the angle that results in theta x being 90 degrees. So how do I find what theta x is? Snell's law, right? So it says index of refraction in here times sine of the angle in here is equal to the index of refraction out here, which is 1, times sine of this angle, sine of theta. Alright? But if theta x is 90 degrees, that's where I hit my critical point. It can't go past 90 degrees. Then this is just going to be equal to 1, right? So what we want is theta top, well, we want this to be bigger than 1, which means that theta top needs to be bigger than the angle that makes this equal to 1. So at what angle is theta top? Does theta top result in theta x being 90 degrees? Well, we just set this to 1. We say n sine theta critical. That's theta critical is the angle theta top needs to be in order for this to be 90 degrees. That's equal to 1. So if I solve this, I find then that theta critical is equal to the inverse sine of 1 over n. Alright? Or in other words, what we want is we want theta top to be bigger than that angle. So we want theta top to be greater than the inverse sine of 1 over n. That's what we want. Okay, but now we know what theta top needs to be in order to get total internal reflection. How does that relate to theta 1? Well, we need to find theta top in terms of theta 1. Well, there's a couple things going on. Let's first of all, the light enters the glass and it refracts. So let's call this angle right here theta 2, and I can find theta 2 in terms of theta 1, right? I just use Snell's law again. The index of refraction out here is 1, so 1 times sine of theta 1 is going to equal the index of refraction in here, n times sine of theta 2. Alright, so then I can say, oh, well, theta 1 is just equal to the inverse sine of n times the sine of theta 2. There we go. So now I can relate theta 1 to theta 2. Alright? Okay. Next, how does theta 2 relate to theta top? Well, this, if I look at these two normals, because this is 90 degrees, this will be 90 degrees, and I've got a right triangle, and so I know then that these angles have to add up to 180 degrees, so theta 2 is just going to be 90 degrees minus theta top, right? So that means I can plug this into my equation and say theta 1 is the inverse sine of n times the sine of 90 degrees minus theta top, right? But sine, if you think of sine, right, cosine starts, for small angles, cosine starts at 1 and decreases as the angle increases. Sine is 1 at 90 degrees. If I start at 90 degrees and start going down, it starts to go down just like cosine goes up. So you may recall then, that means I can use a trig identity. So I'm going to get inverse sine of n times sine of 90 degrees minus something is just cosine of that something. All right? Okay, and maybe I should have solved this for theta top rather than theta 1. All right? But anyway, here's what I have. And I know that I want theta top to be greater than the inverse sine of 1 over n. All right? As theta top increases, this decreases, which means inverse sine also decreases, right? If I start at 0 and go up with my cosine goes down. But if I start with a small number and go up, a sine goes up, which means the inverse sine of something going up also goes up. All right? So if I want theta top to be bigger than something, that means that I want theta 1 to be smaller than sine, inverse sine of n cosine. Our limit on theta top then is going to be the inverse sine of 1 over n. So there's the equation that I want. All right? So I just substituted in what my limit was on theta top. All right? Now, if it confused you how this turned into a less than rather than a greater than sign, one thing you can do is you could just set them equal, find the critical point, and then try a point a little bit above that and a little bit below that and see what happens. All right? But this is indeed what happens. So theta 1 has to be equal to less than the inverse sine of n times the cosine of the inverse sine of 1 over n. All right? So we can calculate what that is because we know what n is. All right? So I'll just summon Python, import my trig functions from math import. If you don't know Python, it's a great little programming language, and it makes a great math tool too. So we want to find the inverse sine of, let's set what n is. N is equal to 1.4. Okay? Then I want to know the inverse sine of n times the cosine of the inverse sine of 1 divided by n. How's that? And it tells us, I'm missing a parentheses. There we go. So there's my answer, but that's in radians. Python does things in radians. We like things in degrees. So let's multiply by 180 degrees and divide by pi. 78.46. So 78.5 degrees. So theta 1 has to be less than 78.5 degrees in order for us to get total internal reflection up there. Ta-da, we're done.